Hello, good morning. I hope you guys are enjoying the summit so far. I am. My name is Sean Alexander, and this is my colleague, Jithan Wajib, and we are here to present to you how American Airlines is self-servicing authorization using the Add Policy Directive. Specifically, how do we use it using OPA, Backstage, and GitHub? So let's get right into it. So here's the forecast for today. We're going to meet the team and what our mission is. We are expecting some turbulence, but we will discuss a path forward with a solution. Finally, we will make a smooth landing by outlining the business values and key takeaways from our approach. Let's meet the team. So we're American Airlines. We're the world's largest airline operating the largest fleet, and we serve nearly 6,700 flights a day to around 350 destinations. Specifically, we're from the Enterprise Data Services team for American, and we provide shared services that are vital for the airline. In regards to API management, MQ messaging, file transfers, databases, data transformation, anything that has to do with movement of data, we deal with that. But we're just getting started with setting up the Apollo GraphQL platform for the enterprise. In fact, we just started since last year's summit. But American is not new to GraphQL. We have other verticals within the company that have been on their journey for some time now. But now as a platform team, we strive to stitch those graphs together and increase adoption at an enterprise scale. So this brings us to our mission. What is our mission? Our mission here is to provide secure and reliable enterprise GraphQL platform for teams to easily access, contribute, and consume supergraphs. So while we were on this journey to set up the GraphQL platform for the airline, we wanted to ensure that we provide the best possible experience for our teams to onboard and consume the graph securely. But we had faced some challenges in regards to authorization. See, it is easy to do authentication, which gets our users into the door. But how can we set up authorization so that we can provide granular access to the data the users need? Today, we can implement the @required scopes directive. By using this, you work with the IDP provider to provision scopes and claims in your JWT token, as you can see on the top left. The JWT token is then, as part of your request, is sent to the router where it'll be extracted and data is retrieved and your data is returned back to you securely. The challenges in the purple circle over there is, what does it look like with provisioning these scopes and claims with your IDP provider today? What does it look like to provision it, to request access to it? How do your clients, get access to the scopes? This may look a little bit more complicated in a large enterprise. It may look easy in a small one. Do they involve graph owners in the process? If a client needs to request access to a scope, are the owners of the graph notified? Those are some challenges. So we'll talk about the challenges. There are 4 main challenges when setting up GraphQL using the @required scopes. The first challenge is the lack of reliable authorization, right? Obviously, without it, we cannot determine which services or users can access specific backend integrations. But graph owners have limited control over who can consume what data, which can lead to potential risks and data exposures. This may lead to security concerns in maintaining consistent security across multiple services and risks associated with unauthorized access and data breaches across the enterprise. The third challenge is compliance friction. Meeting regulatory requirements across diverse teams and environments can be demanding and can lead to high costs and efforts to maintain these standards. And lastly, it's reduced developer velocity. The time spent on coordinating and provisioning scopes and claims through a centralized IDB team. As you can imagine, in a large enterprise such as us, this can be a pretty time-consuming process which can take days or maybe even weeks. And there is lack of self-service capabilities to provision these attributes. So the main business problem we're trying to solve here is, how can we enforce authorization without compromising reliability and velocity? So I'll pass it on to Jithan to talk about the solution.
Hi everyone, good morning. Thanks Sean for explaining all the challenges we have faced during our GraphQL implementation POC. So when we were facing these issues, we had a meeting with Apollo team and we were looking for some solution from them. So the solution was proposed was the @policy directive. So I can say that this @policy directive was really a game changer for us. It was like a complete solution for the authorization. So let's see how we can enhance authorization in GraphQL using this @policy directive. So today in our digital world, ensuring a secure and precise access to resources is more critical than ever. Traditional authorization systems, right, basically relies mostly on basic scope and claims, which can be restrictive and lack flexibility. So the @policy directives takes authorization a step further by allowing us to define the policy directly in the GraphQL schema. So this means we can just go beyond an yes or no permissions, creating a fine-grained control on who can access what and under what condition. Imagine being able to specify the access not just at the user level, but at the specific resource level or at the field level. That is what exactly the @policy directives enable for us. So here is a screenshot of a sample GraphQL schema. So you can see that we have defined two @policy directive policies. One is read profile and another is read credit card. So if you see that read profile we have defined at the policy level and read credit card is at the field level, credit card. So if a particular client wanted to access these fields, the client should have access to both these policies like read profile and read credit card, right? And also the read email. So suppose that particular client is not having access to the read credit card, then the client will get all the other data, but not the credit card because the client is not having access to the read credit card policy. That is the way we protect any particular field using this @policy directive. So now let's see about external coprocessor. So let's see like how we can extend the behavior of our GraphQL environment using an external coprocessor. So coprocessor provide a unique way to enhance the behavior of our router using any programming language, offering a flexible and powerful way to implement custom logic at any stage of the request handling lifecycle. So as you see in this diagram, whenever a router receives a request at any stage of the request handling lifecycle, it can send an HTTP post message to coprocessor, and coprocessor can implement any custom logic as per our requirement and send back the response to the corresponding same stage. Okay, so in our enterprise, we have implemented the coprocessor using Node.js, and we are operating it at the supergraph level. So here, if you see that the client is sending a query to our router service, and at our router service level, like we are calling the coprocessor. So when we send the request to coprocessor, what it will do is first, as soon as the request reaches the router, it will just check the query against the defined schema to make sure that the query is valid or not. After that, when it detects an @policy directive defined in the schema, it basically like take the policy name and insert in the request payload context and send to coprocessor. So coprocessor, we have defined a basic logic to extract the policy name and also the client ID from the message and make a JSON message. That JSON message will be subsequently sent to the next key component in our setup, that is OPA. OPA, like we will discuss in the next slide. So OPA is a open source general purpose decision making engine which allow us to define and enforce policy across the application stack. So one of the major advantages of OPA is that it decouples the policy from your application or service, allowing us to manage the policy independently from our code base. This separation simplifies the development process and make our system more reliable and maintainable and adaptable to this change. The OPA follows a policy as a code approach where we define the policy using a programming language called Rigo. So if you see the screenshot, in the left side, you can see the policy we have defined using Rigo. And in the right side, the first is input. Imagine this is the input we are getting from the coprocessor. And we have a data in JSON format. This data serves as the source of truth for validating this input. So how this OPA will work is, when a request comes with the input JSON format, using this data and also with this policy, the OPA will evaluate when compared to this data, it will evaluate and find out that the user is basically checking like if the user 2 is having access to read profile and read credited policy or not, right? So based on this data, it is able to identify that the user 2 is having access only to read profile. So that output will be in JSON format, and this output will be sent back to coprocessor and then back to the router. So that is the way the OPA take the decision. Okay, so let's see the next component here, that is Backstage and GitHub. So this Backstage and GitHub is one of the main component we have in our setup. So let's see like how we utilize the Backstage and GitHub in our GraphQL implementation, specifically for managing and enforcing the policy. So as you know, like Backstage is an open source framework for building developer portal. It provides a centralized hub for developers where developer can access all the tools, service, and documents they needed. So we have taken the advantage of Backstage for creating a custom plugin that help to manage and implement the GraphQL policies. So in our environment, in American Airlines, we call this Backstage plugin, Backstage portal as runway. So any subgraph owners who wanted to create a new policies can use our custom plugin and provide all the information related to policy, so that what will happen is it will update the GitHub with a policy folder, like it will create a policy folder in the GitHub. And if a particular client who wanted to access the same policy also can use the same custom plugin by providing their client ID, contact information, and everything. So what will happen is it will create a pull request against that same policy folder, and it will be assigned directly to the subgraph owner. So the subgraph owner can review the pull request, and if the pull request looks good, they can approve it and merge it. So after merging, from that time onwards, the clients can start consuming the fields related to that policy. Okay, so that is the way we manage our policy onboarding and also provisioning the access related to the policy. So this workflow not only streamline the policy management process, but also ensures that all the changes are tracked, reviewed, and implemented consistently across the GraphQL environment. So this is a flowchart diagram which for related to whatever I discussed till now. So in here you can see that in the right side, the client is sending the request to the router server, and at the supergraph service level, we call the coprocessor. So the supergraph at the router adds the policy name and the client details in the policy in the payload context and send to coprocessor. So coprocessor extract the policy name and client ID, make a JSON message, and that will be sent to OPA for the policy validation. Right? So OPA, we have the one configuration to poll the GitHub, like each defined interval. So in our case, like we are polling each 10 minutes to GitHub. So in the left side, you can see that the client or the subgraph owner can use our custom plugin, which we developed using our Backstage portal. So they can use that to create a new policy and also get access to the existing policy. So whenever they use our plugin, the changes will happen to the GitHub. And in GitHub, we have a pipeline. That pipeline, what it will do is it will use the policy details and also data. It will club that and make a bundle tar file. So the OPA will poll the GitHub and get the tar file and use that tar file for the policy decision making. And OPA take the decision and send the response back to coprocessor and then to router.
Thank you, Jithan, for going over the solution. I know that was a lot of information, so we have a short demo video to show you to see this all in action. I do apologize, we did use an AI-generated voice, and it was sped up, so it could be unclear at times, but bear with us. Let's play that video.
This is a short demo on the self-service of the app policy directive using GitHub and Backstage. Here we are at the Apollo Explorer, under our supergraph and variant, and we are going to query the user's subgraph and all its fields. So you can see I'm unauthorized, so I'm going to pass in the JWT token from the op0 domain. And now I'm authenticated, and now I'm able to see all this data from this subgraph. Some of the data fields include phone number, email, credit card, and along to status. In this particular example, we want to detect the credit card field for PCI reasons. We can do that with the app policy directive. So that way, when a client comes in and query against this subgraph, they will not be able to see the credit card unless they are authorized to do so. So what we will do now is we will create a policy for this field, and we can do that with the Backstage plugin. Here we are at the Backstage plugin for Apollo GraphQL, we have built in-house. The first tab is actually pointing to the Apollo Explorer plugin built by Apollo for using your Explorer tab for your own graph. The second tab is the custom plugin that we have created for creating and requesting policies. In this case, we're going to view all the policies in the test variant. There are two policies right now, the read profile and read rewards. These are the owners for this policy and their product. This is the description of the policy, in this case to read profile information, and for this policy it's to read rewards information. And you can see the list of clients that are approved to use this policy. And so what we will do is we will create a policy for our credit card field. Once I create this policy, it should create a pull request in our GitHub repository for managing our policies. Let's go there now. As you can see here, add a pull request waiting, and this will include a code on this file specifically for the read credit card policy, so that any requests in this folder and this policy will require that the owner approve it. And this is the JSON body for the policy information that it contains the owner information, email, and a description. And you will notice that the client list is empty as there are no clients with this policy yet. And we will go ahead and merge this. Once it is merged, a get a bastion should get executed. And what will happen here is it will compile the OPA bundle, which will be a bundle to cart GZ file that will contain this new policy information. In the background, our OPA process is pulling for this bundle every 5 minutes. Now that we have created this new policy for read credit card and published it for the OPA, we can now update our subgraph schema to include this new policy. So here's the subgraph that we were tearing earlier. And we're going to go ahead and update the credit card field to include this new policy direct us. So you can see here, this is the credit card field, and we're about to use the policy directive followed by the name of the policy we just created using the Backstage plugin. And so they're gonna go ahead and merge this. This should kick off the deployment to Apollo Studio by running rover schema checks and rover publish. And as you can see, that the subgraph has been updated in our supergraph. So if we go and back to Apollo Explorer and query against this subgraph, we should see that this credit card field will become hidden. And there you go, it is detected for the add policy collective. As null, you can see that it'd be messaged below that I monopolized to see this specific field, that this JWT tilting. Now that our subgraph is protected with an add policy directive at the credit card field, we will now demonstrate how their client can request access to this specific policy. The JWT token that we have generated from auth0 provides details of the claims. In this case, the name of the client will be Sean Alexander. This is important to note. This is what we will evaluate it against. So we will now go back to the Backstage plugin and request access to that auth. So if I go back and query this test variant and see now that a new credit card policy has been published, with the owner being Sean Alexander and the description is to read credit card. So we did not request access to this policy by requesting the policy and providing that client ID that we got from the JWT token. And I'm just going to use an example, and a product name. This will now create another PR on that same pull request for the DAFDRA policies repo. Switching back to that repo, I now see that a pull request has been created, and you will see that the owner of that policy, Sean8126, will be requested to review this specific request. Without this person's approval, this policy will not grant that request to this client. And the changes will include just adding that view client into the client array list in this JSON. So you can see here for the read credit card policy, they're requesting that this client get access to this policy. We'd rather go ahead and approve this and merge this policy request. Once the request for this new policy has been approved by the policy owner, the bundle is regenerated and the OPA will pull this bundle every few minutes. As you can see in the test variant, the credit card policy now has a new client that is approved to use this new policy. And with this client being embedded in the JWT token, we should now be able to go back to their Apollo Explorer using that same JWT token and query the data, and you can see that the credit card field is that showing through the use of the app policies directive. Let's come across the demo of showing how we can create a new policy and request access to that policy using GitHub and Backstage.
I hope that demo was helpful. So let's talk about the business value from what we just saw. By self-servicing the add policy directive, we are driving business value in 4 ways. The first is by empowering our developers. We increase developer velocity because we can now create, request, and update policies for authorization without waiting for a centralized team. We put the client request in the hands of our graph owners. This enhances productivity by reducing bottleneck and allowing faster development cycles. The second value is ensuring compliance and security. We now have consistent policy enforcements across all services by using the add policy directive along with claims and scopes. By making it super easy to apply secure guardrails, we minimize the chances of security breaches and non-compliance penalties. The third business value is cost savings. We have less need for custom security code across services and programming languages. And we've automated compliance, thus reducing the need for manual audits and interventions as well as other time-consuming tasks. We are also able to avoid huge fees due to data privacy penalties. And finally, it's platform enablement and growth. We're able to scale by increasing the adoption of the platform through easy onboarding, and we're quickly able to adapt to new business needs and regulatory changes. So now we're ready for landing. Here are some key takeaways that I want you to take away from this session. The add policy directive allows fine-grained control over access to the supergraph, and integrating the code processor and the open policy agent offers comprehensive solution for policy evaluation. GitHub enables collaboration and approvals on policy changes, and we were able to use the PR system as well as the notification system that's built in with it. And we didn't have to build custom code for that. Backstage Developer Platform helps make onboarding and adoption of GraphQL easier. We created that policy management plugin that you just saw, but we also use software templates to create subgraphs from scratch and deploy them easily to production and any other variants quickly. So that's what we have there. And self-servicing the add policy directive increases security, compliance, and developer efficiency. And it is setting a new standard in the industry for secure and scalable GraphQL platform. So in conclusion, the adoption of self-servicing the add policy directive is not just about enhancing security. It's about transforming how enterprises think about and implement security and compliance. The shift not only protects the organization, but also drives innovation and efficiency, placing the company for sustained success in the digital era. So lastly, I want to give a huge shout out to my amazing crew who made all this possible. So thank you. Thank you.